In this video, we are going to learn about question number 4. Question number 4 of the EOT, the writing part. Okay. So, A part, develop a mathematical equation. Okay, we need to derive to describe the electric potential of a point charge. This is the major thing, which you need to focus. Point charge. Okay, first we need to solve for the point charge or many point charges, means combination of charges or distribution of different charges. Okay, first we will solve the question A or part A. So first for the single charge. Okay, and then we will solve for the multiple charges. So as per the definition, we know what is the electric field and what we are solving, the electrical or electric potential. We need to solve the value of V. What exactly the value of V? We know V is equals to integration negative infinite to R E dot dr. Okay, just wait, I'll let you know how to solve this so that you can understand the formula also. We need to find the electric potential. Let's say there is a charge Q who is at infinity, okay, and from there line of forces are coming. Do you understand? Which line of forces? Electric field. And let's say there is a point P and I need to find how much value of potential, means how much power he is feeling because of this charge Q. Do you understand? Again, any charge which is placed at infinite and the electric line of forces are coming out, and we need to find out how much electric field or electric potential this point P is feeling because of Q. So can I say the initial point is your infinity and final point, let's say we define with any distance r. Clear? Okay, now as per the definition, we have an equation V equals to negative integration. What is the initial? Okay, infinite. What is the final? R. And we have an equation E dot ds, or you can say better, instead of ds you can write dr for the better understanding. Okay, now we have a dot product. What we have? Dot product. So we know a dot b, which is equals to a b cos of theta. Yes or no? Okay. Second thing, E vector will be represented as E times E cap, and dr vector will be represented as dr vector will be dr into dr cap. Fine. And both the things are here in the same direction. So you can say theta between them is 0 degree. Cos 0 degree is equals to 1. Now solve this point. V equals negative integration infinite to r. So E dot dr, can I write E dr cos of 0 degree? Cos 0 is 1. So what we get? Integration negative infinite to r E dr. Clear? Till here clear? Okay, now integrate. Now the step number 2. Step 2 is integrate. So after integration, what we get? V equals integration of this side, E is outside, integration of dr, and even you can place the value of E, so it's easy to solve in one step. So negative integration. So what is the value of E? We know k times of q over r square dr. I will write it here for you in the box. We know what is the value of E? K times of q over r square. I just replace the E. Okay, infinite to r. Solve this. Negative infinite to r. So take this value k and q outside. That is better. First take out common values k and q outside. Bracket integration negative infinite to r. Take r square up. r raised to power negative 2 dr. Clear? Okay, minus kq, solve this. So you will get r raised to power negative 2 plus 1 over negative 2 plus 1. And the limits are infinite to r. Fine? Okay, there is an extra sign. Remove this. Okay, now the next part. Okay, here, so we have v equals negative kq outside, and now I get r power negative 1 divided by negative 1, and we have a limits infinite to r. Okay, v equals negative kq. So I get negative 1 over r. I take r down, infinite to r. Upper limit minus lower limit, negative kq. Upper limit, negative, negative, positive. So 1 over r minus 1 over infinite. Clear? Upper limit, upper minus lower. Clear? So what we get? Q over r, because we know 1 over infinite is equals to 0. So this is our value of v. Fine guys, this is for single charge. This is for single charge. Okay, now for we have for single charge. Now we have something else also for the multiple charges. Okay, many point charges. Okay, I will explain this with the help of a question. Okay, I'll add a page so that it's better for you and you will understand in a better way. Okay, time to make it big. Okay, now for case number 2 for multiple charges. For multiple charges. Okay, just think how to solve multiple charges. If you have lots of charges, and how can you calculate this value? As we know, for a single charge, how we are solving? What is the equation we have? Single charge. So we have a value. V is equals to positive kq over r. Kq over r. Let's say for multiple charges, we have number of charges here and how to solve them. Let's say this is your Q1, okay, positive. Let's say this is your Q2 positive, Q3 negative, Q4 positive, Q5 or Q6 like that, okay. And there is a point P. You need to find the value. So because of Q1, can I say this is the distance? Yes or no? Let's say this is your R1. Because of Q2, can you say this is your distance? This is your R2, because everything depends upon the R. Because of Q3, can I say this is your distance? Not like this. Can we say this is our distance? I'll change the color. R3. Because of Q4, can I say this is your distance? R4. All distances are different. So can we say that V1, V2, V3, V4 are different? So what is the total value? V should be equals to V1 plus V2 plus V3 plus V4. Okay, you can solve like this. What is V1? Okay, solve V1. K times of Q1 over R1. Similarly, V2 is KQ2 over R2. V3 KQ3 over R3. V4 KQ4 over R4. Just add them, and with their signs also. So V equal to K times. So can I take K common from everyone? Q1 over R1 plus Q2 over R2 plus Q3 over R3 plus Q4 over R4. Do you understand? Let's say their sign also. Might be someone is positive, someone is negative. So can we say K over positive Q1 over R1? I'll change the color. Plus Q2 over R2 negative. Q3 is negative. I told you it is negative. Q3 over R3 plus Q4 over R4. See, if you need to simplify, this is the simplified formula. If you need to find anything, so just split them one by one and you can solve them. But now, what is the equation? That you need to understand. If I conclude this V, okay, so which is equals to K times of summation. I write summation. I equal to 1 to I equal to n. Let's say these are 4 cases, so you need to take 1 to 4. Okay, Qi divided by Ri. You can place the value 1, then you will get, when you put I equal to 1, you will get Q1 over R1. When you put I equal to 2, Q2 over R2. Do you understand? Up to n value. So this is called a summation value. This is called a summation value. Fine. Okay, now there is one important thing what you need to understand about their graph and how the things are going to change. As I already mentioned you in the previous videos, but I will just for a brief introduction, I will tell you, we have a positive charge, positive, and we have negative charge. So in case of positive charge, we know line of forces starts from the surface and they are going outward. Do you understand? And in case of negative charge, they starts from infinity and ends at surface. Do you understand? And they starts from surface or begin from surface. Start from surface. Yes or no? So if you have a positive potential, so can I say positive KQ over R? And if you have a negative charge, can we say negative KQ over R? So just draw the diagram. Try to understand the diagram. Huh? This is very, very important diagram and the graph. Okay. In terms of, let's say this is your y-axis, this is your V, and this is your R. So once you start, this is your starting point. Huh? So you can tell me in positive charge, you have the maximum value here. Okay, I will write. So at the point of beginning, can I say maximum V? And when we are going towards infinity, that is your minimum value, minimum V, which is equals to 0. Yes or no? Do you understand? Now see from the graph also. So graph starts from here, the maximum value, and it is keep on going down, 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 up to 0. Do you understand? Again, when starts, this is called the maximum value, max. Where is the maximum value? Surface. Okay, when R tends to infinity, means reaching towards infinity, potential will become 0. Fine? Okay, second case. For in case of negative, you need to understand now. Just try to understand, I told you, when it starts from infinity, this is your infinity point. So what is the value of V? Maximum. Do you understand? And what is the value here? Minimum, which becomes 0. Do you understand? So same thing you need to focus in the graph. Let's say this is our graph. So this is our negative V, and this is your R. This is in the quadrant number 4. So you can understand this point. Yes, and it is reaches toward this. So this is, you can say, the maximum value at infinity and minimum at surface. Clear? And which will be 0. Clear? And this is the negative value, but this is the maximum value in terms of magnitude. Fine, guys? Okay, so now we have the next part in which we have to learn about the electric field. We need to know how to find the electric field with the help of potential. Okay, so what exactly we have? Finding the electric field. What we need to find the electric field with the help of electric potential. Okay, we need to use all these things. Huh? Okay, let's see. We have a simple formula for work done. From grade 11, you know this thing. Work done. So what is the formula of work? W is equals to force time displacement. Okay, this is the complete work done. If I say small work done, you can say dW is equals to force times small displacement. Fine, clear? Okay. Now this is the equation number 1. Second equation, we know as per electrostatics, force is equals to Q times E. This is your equation number 2. Yes or no? Okay, place it here. So place equation 2 in equation 1. So you will get dW is equals to Q times E dot ds. Fine, guys? Okay. Now what we need to know, step number, this is the 3 steps. Okay, now step 4, which is the major step. We know what is the relationship between the potential and the work done. Relationship between potential and the work done. Relationship between work done and potential difference. Okay, so we know they are in opposite directions. So can I say change in potential is equals to negative change in work done per unit charge? We know now potential difference is equals to work done per unit charge. So if we are looking for change or the small amount, this should be the formula. Okay, so this is your equation number 3, this is your equation number 4. Place equation 3 in equation 4. Place equation 3 in equation 4. So what we get, dV is equals to negative QE dot ds divided by Q. Yes or no? Okay, charge and charge cancel. So what we get, dV is equals to negative E dot ds. Clear? Okay, now this is the easy way. So here we have the dot product also, so we can use the cosine theta to solve. And there are the other things. If we need to find the components, okay, sometimes they will give you the question on the basis of components, on the basis of components. Then how can you solve this? So we know dV is equals to negative E dot ds. Okay, so can I say E is equals to negative dV over ds, complete value? So you can split this value into 3 parts. Along split into x-axis, y-axis and z-axis. So in that case, you will get Ex equals to negative curl by dx. Just remember, this is not derivative, this is curl. This is called curl. It means that you can solve only x value and other values remains the same. Here, Ey is equals to negative curl dv over curl y. Okay, and here Ez is equals to negative curl V over curl Z. I'll give you a formula, simple example. Let's say V is equals to 2x square plus 3y plus z cube plus z cube. I told you when you are solving the curl, only that value will work. Let's say when you solve curl V over curl x, you can solve only x, y and z becomes constant. So how will you solve? For 2x square, when you solve, it will become 4x, 3y becomes constant, 0, z cube becomes 0. So what is your value? 4x. Similarly, when you solve curl V over curl y, x factor becomes 0. 0 plus 3 plus 0. When you solve curl V over curl z, so 0 plus 0 plus 3 is z square. Clear, guys? So in this way, you can solve the curl value and you understand the formula. So you can use in either way. You can solve this one dv is equals to negative E dot ds. This one formula, or you can use E is equals to minus dv over ds, or in terms of, instead of s we generally use E is equals to negative v over r, negative v over r. Clear? You can use this one, or you can use negative E dot r, this one, in any way you can use it. Clear, guys? Okay. Okay, now we have the last part, that is the definition of the electric field. So what is electric field? Simple thing. Electric field is force per unit charge. Just highlight the part. What is electric field? Is force per unit charge. Force per unit charge. And you have this equation, E is equals to F divided by Q. And what is the unit we have? Newton per Coulomb. And guys, remember one thing, they are going to ask you number of units. So you should remember the units and the dimensions. Focus, focus. Focus on units and dimensions. So these are very, very important. Okay, in case of positive charge, this is important point. In case of positive charge, let's say you have a positive charge and the direction is outward, electric field and force is also outward. Clear? And in case of negative charge, it becomes opposite. Clear? So in case of, you can say, attraction and repulsion, the things are opposite. Fine, guys? So this is our electric field, this is our potential difference, and the graph, which are very important. You need to focus on these points. Fine. So this is our question number 4.